Hello, good people of pre-calculus. This is Mr. Klein coming to you from Klein Studios in the heart of the G-Wing. And today we're going to be talking a little bit about how to get you launched on Unit 5, which is going to be about systems of equations. We're going to start today with talking about linear systems, which means that every system that we work with today is going to be a line. So a system means that we have more than one equation, usually two, and there are three methods for solving linear systems. They are graphing, substitution, and elimination. You have seen this before. This is a reminder video. I just want to make sure that you are first good with graphing. So let's look at this first equation. This is in what we call point slope form. But before I go any further, I should mention that system means that we are looking for the point where these two lines intersect. So this is in point slope form, and that means that we can identify a point where the x value is 2 and the y value is 1. We know that it passes through that point. You can check. If you plug 2 in right here, you'll get 0 plus 1 is 1. And then this number in front right here, that is our slope. So I'm going to come in over here. I'm going to plot this line. 2, 1 is right here. The slope is 5/4, so I can go up 1, 2, 3, 4, 5 over 1, 2, 3, 4. And then I can go down 1, 2, 3, 4, 5, and back 1, 2, 3, 4. And it looks like those 3 points are the only 3 points that are on this particular graph that I'm going to catch. Now the second one here, this is not in point slope form. This is in what is called standard form of a line, which means that the x and the y term are either added or subtracted on the same side, and the constant term is on the other. When you get something that's in standard, you need to change it into our favorite form, which is slope intercept. And so in this case, we would do that by subtracting x from both sides, which would leave us with 2 times y is equal to negative x minus 10. And then we would divide both sides by 2, which would give us y is equal to negative 1 over 2 x minus 10 over 2 is 5. So now we can plot this one. We know that our y-intercept is going to be at negative 5. We know our slope is negative 1/2, so I can go down 1 and over 2, down 1 over 2, back 1, up 2, back 1, or back 2, up 1, back 2, up 1. Okay, so we've got our two lines. They have different slopes from each other, and so that means they are going to intersect, and they intersect right at that point right there. And that point is negative 2, negative 4. So this is the solution to our system. This is the point that is on both of these lines. I do want to mention one other thing to you, and that's that this is called a consistent system. And a system is going to be consistent anytime they have different slopes, and so they intersect at one point. Okay, let's do another one. Let's take a look at a substitution problem. Substitution is a good method to use when it is easy to isolate one of the variables. And so I see two equations here, and this one has just a plain old y in it, and that y seems really easy to get by itself. You're going to see me work these problems in a T format. I like to write the two linear equations up here. And then I'm going to start by getting that y by itself, which means I'm going to subtract 2x from both sides, which would leave us with y being equal to negative 2x plus 5. And then the idea of substitution is that we now know that y and negative 2x plus 5 are equivalent to each other. So anywhere that we see y, we could replace it with negative 2x plus 5. Well, I see a y over here. So I'm going to take this and I'm going to cut, I'm going to copy, I'm going to paste it, I'm going to bring it over here, and I'm going to plug it in. Which means that the equation on the right side is going to end up being 3x minus 2 times the quantity, negative 2x plus 5. I replaced y, I substituted y with something that it's equal to. Is equal to, on the other side, 4. Why is this helpful? Because we get this big, ugly equation? Well, the answer is that this big ugly equation only has x in it, which means that we can now solve for x. I'm going to change this to a negative 2 and distribute to get rid of the parentheses, giving us 3x plus 4x minus 10 is equal to 4. And then we would get 7x right here. I'm going to add 10 to both sides, which would give us a 14. Therefore, x is going to be equal to 2. 7 times 2 is 14. Okay, now we're not quite done. Our goal is to find that point where these two lines intersect. We know that it has an x value of 2. We need to find the y value. And conveniently, if you grab that 2 and you bring it back over here, you can just plug it in to this equation. The y value is going to be equal to negative 2 times 2 plus 5, which is equal to 1. This point is the solution to our system. The last method, elimination, is helpful when you don't have a variable that's easy to get by itself. Notice how the x and the y and the x and the y, all 4 of those variables have a coefficient in front of them, as opposed to right here where one of them didn't. So the idea with elimination is you are going to eliminate one of the variables by creating opposites. Now, I'm going to choose to create opposites with the y values right here, but I could just as easily, or almost as easily, create opposites with the x values. Our coefficients are negative 4 and 6. Those are going to be our important numbers. And so you want to think, what is a number that has both 4 and 6 as a factor? And the number I'm coming up with is 12, right? 4 is 12 times 3, and 6 times, or well, sorry, I said that wrong. 4 times 3 is 12, and 6 times 2 is 12. So these are both factors of 12. And then what I'm going to do is I'm going to take both equations and I'm going to multiply it by something to make 12s. So in this case, I'm going to multiply by 3. In this case, I'm going to multiply by 2. Let's see what that does. The first equation would become 3 times 3x is 9x minus 3 times 4y is 12y is equal to 3 times 31 is 63. Second equation, 2 times 7x is 14x plus 2 times 6y is 12y, oh, there's our opposites, is equal to 2 times 57 is 114. Take the two equations that you got right here, add them together. When we add them together, right here we're going to get 9x's plus 14x's is 23x. Plus, this is the key right here, negative 12y plus 12y is 0. The y's disappear. 63 plus 114 is 207. So this equation simplifies to 23x is equal to 207. I'm going to divide both sides by 23 to determine the value of x. 207 divided by 23 is 9. So we're almost done. We know that 9 is the x value where these two lines intersect. We need to find the y value. You need to pick one of these 4 equations right here. I am going to pick this one because the numbers seem the smallest. Bring it on down here. And you're going to plug that x back in. So 3 times x is 9 minus 4y is equal to 31. So 27 minus 4y is equal to 31. Subtract 27 from both sides. Negative 4y is equal to 4. Therefore, y is equal to negative 1. And there's the solution to our system using elimination. All right, so now it's your turn. On the next page right here, I would like you to attempt problems 1, 2, 3, 4, and 5. Hit the pause button right now, attempt the problems, and then you're going to come back, unpause it, and see what the answers are. And I'm probably going to say a couple words about at least this one right here, which is a little tricky. Okay, we're back, and we're going to go over answers now. The first one, the answer is 5, 1. Number 2, the answer is negative 5, 2. And number 4, the answer is 14, 10. I'm going to talk about number 3 and number 5. Number 3, I got my work started here. I took the second equation and multiplied by 2. That created opposites here. Now, it also created opposites here, so when I add the equations together, I get 0 is equal to 6, which last I checked is not the case. So here's what's going on. If you get something like 0 is equal to 6, the system is what we call inconsistent, meaning that the two lines don't cross at a single point. In the case of this one, if you get something that's untrue, it means they are parallel lines. They have the same slope, but a different y-intercept, so they never intersect. And that means that there is going to be no solution points. That's what you would write in this case right here. Number 5 is also inconsistent. I took the first equation and I solved it for x. And now I'm going to show you what happens when I plug this in right here. We would get 3 times the quantity 2/3 of y minus 7. Minus 2y is equal to negative 21. And so when I distribute the 3 through here, we get 2y minus 21 minus 2y is equal to negative 21. 2y minus 2y is 0, so these two terms cancel, and we arrive at negative 21 is equal to negative 21, which is absolutely true. So what that means is that in this case, it is still an inconsistent system, meaning that you're not going to get one single point where they intersect. But in this case, the two lines that I gave you, this one and this one, they're actually the same line, which means that every single point on the line is a solution. There are billions and billions and billions of solutions. And here's how you write the solution set. You say it's any point where when x is a, y is some transformation of a. Now you're going to have to do a little bit of work to figure out what goes in this position right here. Pick one of the equations. I'm going to pick this one right here and solve for y. So this would be, let's see, negative 2y is equal to negative 3x minus 21. Divide by negative 2 on both sides. I get that y is equal to 3/2 of x plus 21 over 2. You can change those to decimals if you want, it doesn't matter. But anyway, this is saying that this is the line, So whenever x is a, y would have to be equal to 3/2 of a plus 21/2. So any point that obeys this organization right here is going to be a solution. That's our answer. And that's our video for today.